Good morning, everyone, and welcome to the February edition of the Southeast Climate Monthly Webinar, where we talk about the climate and special topics pertaining to the Southeast region. I'm Sandra Rain, the Regional Climatologist from the Southeast Regional Climate Center, and I will be giving a climate overview. Our guest speakers today are Jeff Dober from the Southeast River Forecast Center, who will provide a water resources overview, Pam Knox from the University of Georgia, who will give an agricultural impact update, and our special topics today include flood climatology in the Southeast presented by Jeff Dober and the new State Climate Summaries presented by myself. We thank everyone for joining us. Just a reminder before we begin, type your questions in the question box at any time and they will be answered at the end. Also, an email with a YouTube link to this recording, as well as a link to a summary of today's webinar, will be sent out within the next day. Okay, let's talk about the climate. Temperatures over the past 30 days have been near to below average across most of the region. Covington, Virginia observed its fifth coldest January on record. We did have a few cold outbreaks throughout the month, including on January 29th through 30th, where parts of southern Florida, including Miami, experienced frost conditions. Precipitation over the past 30 days has been variable, with only a few wet and dry extremes reported. Juncos, Puerto Rico had its 8th driest January, whereas a few winter storms brought over 7 inches of precipitation for the month to Cape Hatteras, North Carolina, and over 5 inches of precipitation to Wallops Island, Virginia. It seemed as if these winter storms would come every weekend. From January 3rd to 4th, a storm brought snowflakes as far south as the Florida Panhandle. As this system moved northeastward, intense snowfall rates led to the closure of a portion of I-95 in Virginia that lasted over 24 hours. Another system on January 16th through 17th brought over 10 inches of snow to Germany Valley, Georgia, and caused over 100,000 power outages. And yet another system on January 21st through 22nd brought over 5 inches of snow to Elizabeth City, North Carolina, and over 6 inches of snow to parts of Virginia Beach. There were also several ice warnings issued with each of these storms, as some parts of the mid-Atlantic saw over a half an inch of ice accumulation. The winter storms also brought severe weather to parts of the Southeast. It is not uncommon to have some severe weather during January in the Southeast. However, this month we had 17 confirmed tornadoes, and we usually only see about 7. The strongest tornado was rated EF2 with winds of 118 miles per hour. This tornado began as a waterspout in the Gulf of Mexico and then moved onshore. It damaged over 100 manufactured homes in the Fort Myers area and caused 3 injuries. Fortunately, no fatalities were reported with any of the severe weather. Moving on to the ENSO update, we are still under a La Niña advisory with a 67% chance of La Niña continuing from March through May and a 51% chance of a transition to ENSO neutral sometime between April and June. The next update, though, comes out this Thursday, February 10th. The U.S. Drought Monitor still shows some exceptional drought in the western part of the United States, and some parts of the West haven't seen any precipitation yet this year. But here in the Southeast, we've improved upon our drought conditions, especially in Virginia and the Carolinas. However, Puerto Rico and the Virgin Islands has remained relatively dry, with moderate drought and severe drought seen across parts of Puerto Rico and extreme drought in parts of the Virgin Islands. And unfortunately, this is expected to persist for the Caribbean. However, the relatively active pattern is likely to alleviate the drought across the southeastern United States. For the next 3 months, we have the probability of seeing above normal temperatures across the region, with the probability of below normal precipitation in the southern part of the region, and the probability of equal chances of wetter or drier conditions to the north. We are still seeing this typical La Niña pattern. For the 6 to 10 day outlook, there's a probability of below average temperatures for the region, as well as a probability of below average precipitation here in the southeast. Speaking of precipitation, it doesn't look like we'll see much through Friday. However, our best chance of precipitation comes next Saturday to Monday, although I don't think it'll be that much. So just to wrap up, the Southeast has had near average temperatures for the past 30 days. Precipitation has been variable. A few winter storms brought snow, ice, and severe weather to parts of the Southeast. We continue to be under a La Niña advisory, and the new update comes out this Thursday. Pockets of moderate drought are observed throughout the region, with severe drought in Puerto Rico and exceptional drought in the Virgin Islands. Our next system and best chance of precipitation comes around this weekend, Saturday through Monday, and the next 3 months will likely be warmer than normal and relatively dry. All right, I'll send it on to Jeff now.
Okay, well, thank you, Sandra. And as Sandra said, after sort of a dry end to 2021, we've really seen it all: the cold, the snow, the rain, and the severe weather. And we'll go to our next slide here, our first slide, and we'll show you how that has affected our stream flows across the region. And it has affected it in some ways after that dry period of November and December, where we were trending into below normal stream flows. That wet weather and the snow and the cold and especially the rain has helped our stream flows rise and continue into the normal level as a whole across the Southeast. The map on the left there, you can see the green dots from the USGS, the map, this is the 28-day average stream flow map, and you can see all the green dots there showing most areas are near normal. Most stream flows are near normal for the 28-day, and then the graph on the right there, you can see our big rise there from really late December into the month of January, and pretty much normal stream flows as a whole. So we'll go and we'll break these down state by state in the next slide, and we'll show you Alabama here, near normal. Really normal is the word for stream flows right now as far as current conditions. Georgia as well, in a period where stream flows typically rise. That's what we've seen in the normal range. The only exception, as Sandra pointed out, Florida's been a little bit drier, so they've been trending in the normal range, just above that below normal range at the current time. If we go to the next slide, we'll move east into the Carolinas, and we see the same signal here in South Carolina, where the Carolinas were getting into some almost drought conditions over there through recent rainfall, and the cold has helped alleviated this, and we see it in the stream flows. Normal conditions in South Carolina, as well as North Carolina and Virginia, a response this time of year that is not atypical. So really normal range across the Southeast as far as stream flows. We'll go to the next slide and we'll show you our current flood conditions. We had some recent heavy rainfall on Thursday night with a pretty good system that moved across the Southeast and brought actually some widespread 3 to 4 inch amounts across the upper Alabama, and even as much as 8 to 10 inches in a pocket in the middle Chattahoochee. And all that water is making its way down a lot of these rivers. Expecting some flooding, only minor flooding conditions in the lower Alabama, lower Tombigbee, and several of the Georgia lower rivers, the Altamaha and even the Apalachicola. We're expecting some minor flood conditions with the recent rainfall. We'll go to the next slide. And we'll show you what we're expecting as we go into the late winter and early spring. As Sandra pointed out, that we do have a trend to more neutral conditions as far as the ENSO. So the combination of current conditions, our trends, current trends, and short and long-term weather forecasts. Right now, we're going to stay with that. As far as river flood outlook, we're staying with that below what is typical. Now, what this means is we will have some flooding, but will most likely the magnitude and the number of events will be less than what's typical for our primary active season. We'll talk about that more when I talk about the flood climatology presentation, but we're talking about below the typical amount of flooding for the Southeast. Meanwhile, I think stream flows will be in the normal range for the most part uh, as we go into the early spring. And that is sort of what I had in the summary. If we go to the next slide, uh, the stream flows, keep them in near normal in the early spring. We may see some of them hover near that below normal range in the Florida Peninsula, as well as in the potentially below normal range in pockets of the Carolinas. We do see maybe some potential dryness across there. But as far as river flood potential, we're calling for below normal across the entire area. Now, again, that means flooding is expected, but the magnitude and the number of flood events for what is typically our most active flood period will be below the typical amount. And that's all I had as far as stream flows and flood expectations, and I will pass it over to Pam.
Well, good morning, everybody. It is great to be back after a month off, and it is a beautiful day here in Athens, Georgia. The sky is blue with just some high clouds. I am glad I live in the Southeast. I don't know about you. Let's jump right into agricultural impacts. We've had some things are starting to pick up now with early season. That's winter, but that doesn't mean the farmers are just sitting around looking at seed catalogs for sure. Some of the things we've seen, there have been, as Sandra pointed out, some dry conditions. They've mostly gone away, but earlier in the month of January, they were still causing some problems for producers in Florida and the coastal Carolinas. And the cool temperatures were also slowing the growth of small grains. I saw some pictures of crops that were kind of turning purple because of the colder temperatures. We had a couple episodes of frost, the biggest of which was on January 30. And my email was just heating up with all the blueberry producers that were worried about that. The frost went all the way down into central Florida and caused some problems with vegetables. The pictures on the left here, the sugar cane in the top picture is showing how much it was burned by the cold temperatures. That will probably grow out of it over time. And then the second picture on the bottom shows a volunteer soybean plant that was killed by the frost. As I'll show you in a minute, we really haven't had frost for almost the entire winter in parts of the Southeast. And they were starting to have problems with crops from last year regrowing. That serves as a reservoir for a lot of pests and diseases. And so the farmers that grow those crops were really happy for the colder temperatures to kill those off. So it's kind of a win for some, lose for others situation. While things are dormant, a lot of pruning of fruit trees and pecan trees has been going on. Those are all taking place while it's still dormant. They don't want to do it too early because then, they can't really get a good clean cut. And we're also looking at some issues with livestock. Cattle were experiencing respiratory issues because of the cold, and also they've been having some problems with low hay quality in some parts of the region. And so those have been issues that have been affecting agriculture lately. If we go on. Here's a map that shows the lowest temperature we had in the last 30 days. And you can see the oranges there are 30 degrees and below. And that stretched through all of our states and halfway down into Florida as well. So there was a lot of problems with the vegetables down there, some problems with corn, and as I showed you with the sugar cane. But areas that were along the coast did a little bit better because of the proximity of the warmer water. And so that has caused some scattered problems in some places. Not as much as I thought, though, which is great. If we go on. This is a thermograph from Elma in Bacon County, Georgia, which is sort of in the southeast part of the state. It's the center of blueberry production in Georgia. And I show the daily temperatures here. You can see, and I put on here a thin red line to show the 32-degree line. You can see there was several frosts in November, and then we had no frost in that area until towards the end of January. So that entire time period, the blueberries were above normal, and a lot of them started blooming almost a month early in some cases. And so they were very susceptible to that frost that came. And fortunately, the farmers there were able to use frost protection techniques like irrigation to really help, I think, with the protecting the berries that are already on the bushes. But there certainly were some losses with that. Some areas got hit harder than others. And you can see it's a long ways until the last chance of frost. You might remember last year, March was really, really warm, and then we had frost in April for a large part of the region. And so we're not out of the woods yet. And I think if you go on to the next slide, this shows the last spring frost dates. There's 3 maps here, and they're color coded so that the yellow is basically this week, February 1 through 10. And if you look at the band through Elma, which is southern Georgia, the last average frost date is the last week of February. So they're not even at the last frost date yet. And you can see 1 in 10 years might occur after the last week in March. So I think the likelihood is that we may still see another frost there yet. We'll just have to wait and see. But that is something to look at. And if you want to look a little bit more detail, I did put the website on the bottom, and I'm sure they can put that in the summary of the meeting later. If we go on, chill hours right now, the peach and blueberry farmers and pecan farmers also are looking at chill hours because the trees do require a certain amount of cold temperatures to produce a good set of blooms. This year, which is in the red, and this is for Peach County, Georgia, which is sort of in central Georgia, just a little bit south of Macon, shows that we have been below normal. We got a good start in November with those colder temperatures, and then in December it very much flattened out. Since then, with the more average temperatures we've had in January, it's been rising again, but we're certainly still below the long-term average, which is that gold color, the top bar. And so at this point, looks like we're probably going to end up near the same as last year. But since a lot of crops are already blooming, those extra chill hours may not provide much help. If we go on. Soil temperature, I will say the soil temperature map is a couple days old, and I think if you pull the one today, that would probably show you the wet conditions that have occurred from last weekend's storm event. And so it'd be a little wetter along the coastal plains there in Alabama, Georgia, and South Carolina. And another thing we start to look at this time of year is the soil temperature, because a lot of planting dates are tied to the soil temperature. For example, you can start to plant corn when the soil temperature averages 55 degrees or higher for 3 days in a row. So we're starting to get into that area. If I had a similar map for Florida, you'd find that some corn is already growing there because there are, of course, warmer temperatures being farther to the south. So we'll be watching that as time goes on as well. And if we go on, across the region the next couple of weeks, this is GFS, which is one model which shows we should get pretty good rains across a lot of the region, except for maybe southern Florida and northern Virginia. And so that'll be great for getting rid of any lingering problems with the drier soils. And for temperatures, I don't have a map here, but temperatures generally show we're going to probably stay cool for the first half of February. And then it looks like there's going to probably be a pattern shift to a much warmer pattern with more winds coming in from the south. And so we will expect to see that. That will probably accelerate the movement of the spring green wave to the north. And so we'll be watching that carefully. If we go on, here's the summary of what I've been seeing. The cold weather has slowed the growth of small grains and also strawberries. The frost killed off some volunteer cotton and soybeans from last year, but did cause damage to blueberries, vegetables, and some other crops. They're still evaluating exactly how much damage that is. Soils may be a little dry, but rain is expected to reduce that, so I don't really see any big increases in drought in the next few weeks. Temperatures probably will stay cool for at least the next week or two, resulting in more chill hours and suppressing the plants, which is probably not a bad thing at this point because they're still so susceptible to freezing temperatures. But it should warm up after that. And I hate to say it, but I think it's likely we probably have not seen the last frost for most of the area north of Florida. And so producers are going to have to continue to watch for that. And that's all I have. And so I think I pass it back to Jeff.
Okay, well, thank you, Pam. And I'm going to talk one of the key on the presentation here. Let me go ahead and show my screen. Okay, can everybody see that?
Yep, looks great.
Okay, super. Thanks, Meredith. Okay, hello, everybody. Again, my name is Jeff Dober. I'm one of the presenters you hear every week or every month. And I'm a senior hydrologic forecaster at the Southeast River Forecast Center, part of the National Weather Service. And our office is responsible for providing river stage and flow forecasts, notably out to the local weather forecast offices. And those weather forecast offices, they issue the warnings and help the public and the public officials with making decisions. So you can imagine that understanding river flood climatology would be important to us, of course. And so questions like what time of year is river flooding most common? What areas see the most river flooding and why? What kind of weather events bring river flooding? These are all important questions that help us better understand our area. And these are all the questions that help our forecasters sort of build this inherent knowledge of the Southeast. So when we first look at the rivers in the Southeast region, we see that really the water can flow into two locations, right? Either the Gulf of Mexico or the Atlantic Ocean. We also see that many originate or have their headwaters in the high terrain, the Southern Appalachians, and they flow south. One exception to that rule is the St. Johns River in Florida, which actually flows north, one of the few large rivers that flow north. Another item we note is that we really don't have a large main stem river like other regions like the Ohio or the Mississippi River. And another key note is we have a lot of flood control, a lot of hydropower in the Southeast. One of the most, as far as regional flood control and hydropower, one of the most compared to other regions. So when we talk about weather features that compose heavy rain threats and thus flooding threats, we know there's several. In the winter and spring, we often see the most notable weather features that can bring widespread heavy rainfall, and that is those low pressure systems associated with strong jet streams that come out of the central Gulf of Mexico. These can be even more impacting when we have any snowpack in our headwaters in the mountains. We've seen that this past January. Another is the tropical systems in the late summer and fall. And what about the summer thunderstorms in the Florida Peninsula, especially the late summer and the sea breeze thunderstorms? So we wanted to try to figure out some answers to some of those questions we had. And so back in 2006, we came up with a methodology that would allow us to have some longevity to the data set we were using. So we took the mean daily flow data from the USGS, and we basically converted to peak daily flow using a calibrated coefficient published methodology of using a calibrated coefficient in the area basin. And so this allowed us to use about 103 of our forecast locations across the Southeast, which had mean daily flow data back through 1975. We wanted a fairly long data set so we could look at different weather features, short and long-term weather features. So the method, I'm going to say it's not perfect. And remember, we did this back in 2006. So there's probably better ways of doing it now, more available data. But for what we needed for our office, it has been pretty effective. So another key item to note is that river flooding is not based on any return period or flow percentage, but it's rather based on impacts at different stages. Those are defined by local weather forecast offices and working with local emergency management. So there are three categories that we use in the National Weather Service, minor, moderate, and major, to depict the impacts of river flooding. Minor is more like nuisance river flooding, usually low impact, not much mitigation needed. Then we go into the two next categories, and these are where potential damaging river flood waters come into play. Moderate river flooding is where we'll have some inundation of property or structures or roads closed. And major is that extreme where we have widespread or extensive inundation of structures or roads, where towns are cut off or inundated. And generally, these are more on the 25 or 50 to 100 year return period. So here is what our data has given us, what our data has found for us. And we see the number of river floods from 1975 to 2020, both minor river floods and damaging, which would be moderate or higher inundation. And we see that really flooding can happen any time of year. But we can see maybe two real flood seasons that come to light. One being the winter and early spring. That's the primary recharge period for the Southeast, basically December through March. And a secondary late summer and early fall season there in weeks 35 through 41. This is October into early November. And this seems to be the only, as we go into this late August and September, October and into early November, this is really our only lull period that we see in the Southeast. And so this for the whole Southeast, but this is for the whole Southeast, but there's differences between the different regions. And so when we break it down region by region or state by state, we first start and look at the Alabama rivers and see the strong signal there in December through early April with a major lull in the late spring and summer into early fall. So not as much of a secondary season in the late summer and fall. And this would entail the rivers like the Tombigbee River and the Alabama River, many hydro projects on these rivers. So when we move over into Georgia, we see a similar pattern there. We see a peak there, a very defined peak in the winter and spring with the primary recharge period, with really the main peak coming in week 10, which is like early March. And again, a pretty defined lull in the summertime. And again, eastward into South Carolina, again, same here, but maybe more late summer fall activity. And this might be hinting at the tropical impact. Not many floods in the late summer and fall, but when they do occur, they're significant. You can see the oranges there, of course, are the minor river floods, and the reds are the damaging or moderate or greater inundation. So those are the significant ones. And again, we see maybe potentially the sign of that tropical influence. And we move over to North Carolina, and it's the same here. More evidence more evidence in summertime and late summer as that fall tropical impact might be true. You can see really moderate events any time of year in North Carolina. Now we go down to Florida, and this is where we start to see even more differences. Florida is really two stories can be told here, one North Florida and one Central and South Florida. But overall, we see much greater river flood season in the summer and early fall compared to the Southeast as a whole. You see there's a large lull there in late fall. That would be like mid-October. It really falls off there. And then when we talk about, now when we look at just the Florida Peninsula, or the South Florida, we call it, South and Central Florida, which includes the St. Johns River and many of the smaller coastal rivers around the Tampa area, we see that the river flood season is tied to the wet season down there, the summer convective thunderstorm season. These would be sea breeze thunderstorms, also the tropical impact. That late summer and early autumn are a classic time for tropical weather and tropical storm rains that can cause rivers to rise. But by week 42 there, which is like mid-October, we see this sharp decline. Basically, the season shuts off quickly. And so what causes these big floods in the Florida Peninsula in the summer and fall, you would think would be tropical, but it's interesting here. Here is the data from a study we did back in 2006, which shows actually it's not always tropical storms that take credit for damaging river floods in the Florida Peninsula. Interesting enough, we see for the whole year, about 2/3 of the damaging river floods are non-tropical related. And during the tropical season, about half are actually non-tropical. We thought this was pretty interesting when we did the study. And when we looked further, we found that it's common during the late summer and early fall to have these cold fronts that really they sweep across the southeast and then they sort of stall along the Gulf Coast and just don't make it south of the Florida Peninsula. So they sort of stall across the Gulf and the peninsula, Florida Peninsula, for days, and they act as a focus mechanism for heavy rainfall and storms. And this really leads to flooding events, especially across the Tampa area. When we look at the Suwannee River Basin, that's the basin there in North Florida. It's a different picture than the peninsula, more like the interior southeast, more of a midwinter and spring signal, peaking in late March and even early April. It seems like that early April period for this basin seems to be when we oftentimes see some of the more significant floods, like what we had in April of 2009. I believe it's 2000, maybe it was 2011. When we look at the seasons and the percent of floods by each location, we see the spring is definitely the largest contributor to the floods, with many locations showing at least 40% of the total during that period. Again, different down there around the Tampa area where it's the summer and fall. You can see the yellow dots there in the summer and fall around the Tampa area. For damaging river events, about half of the damaging river flood events come in the months of February through March and April. And if you add in September, then you have about 2/3 of them in those 4 months. So September being at 13%, not surprising, since the return periods, as you see in that little data box down there, for tropical systems are about one tropical system every year affecting the southeast in September. So we pretty much see a tropical system in the southeast every September. So looking at damaging floods by day since 1975, we see the 1998 El Nino there showing up. But most interesting is the wet February we had back in 2021, or actually 2020 there. We had a significant rain system that month that caused flooding throughout the area. The significant rain system moved across Alabama, Georgia, and up through the spine of the Appalachians and just went floodwaters downstream. So when we look at the top 10, we see that most are in the spring again, but a couple in September, and one, yes, is tropical. That's the Hurricane Francis there in 2004. But that 1979 event is actually, we had a combo basically. We had Hurricane David early in the month, which left very wet conditions. And then later, a very active jet stream brought a large synoptic type storm system that brought heavy rain across most of the southeast, 4 to 8 inches. So not just tropical alone for that September event, which is interesting. The spring storms all have one item in common though, and this is this basic weather setup for heavy rain. That is a large scale trough to the west of the region. And these are all the past heavy rain events, upper atmosphere pattern. And we see the common meteorological setup. And when we look at these all combined or an average of them all, we see, really truly the classic heavy rain pattern. An active southern jet stream, not surprising, which helps sufficient low level jet into the southeast. So this helps us better understand when we take a look at the past floods and see what is the common weather pattern. Helps us better understand when we see this pattern of what we could, when we see this pattern in the future, what we could be seeing as far as flood events. And then, so what about ENSO, El Nino and La Niña and river floods? Here you can see the damaging river floods by month colored in the ENSO event. And we see what we would expect is that many of these active months are in red, meaning El Niños typically do bring wet weather and flooding to the southeast during the winter and spring, especially. But there are some outliers too, like the winter to summer of 2020, where we were in those neutral to La Nina conditions, and the flooding was like we were in El Nino that year. So other atmospheric influences can play a role, but El Nino is definitely one that we watch for. And so on a whole, again, you see it here. This is the floods compared to normal relative to the ENSO. when we compare to the when we have events brought El Nino events bring active flood seasons, especially spring and winter months, as you can see there. Moderate to strong El Nino has brought almost a double number of floods in December. Typically there you can see 200% relative to normal, and almost double through early summer. So La Nina, on the flip side, tends to bring a decreased number in spring and summer, but especially winter. And finally, how do we compare to the nation as a whole in terms of seasonality of stream flow? We see our January to April sort of flood season and high stream flow season. It encompasses most of the Mid-Atlantic and Ohio Valley as well. The Florida Peninsula with the summer and fall, but out west, of course, they have a later peak period as snowmelt is such a big part of the river flood picture out there. So in summary, we see river flooding is most common in winter and early spring, as we said, but there is a caveat to that, and that is that Florida Peninsula area where summer and fall are the river flood season. Though most floods occur in winter and spring, we have a higher percentage of bigger floods in the fall associated with the larger tropical storms. And finally, when it comes to ENSO, El Niños are not well liked on our office as they bring an active winter and spring flood season, making Christmas staffing, of course, all that much harder. So I want to thank you, and now I will hand it back to Sandra.
All right, thanks, Jeff. So I'm going to give a brief overview and kind of bring your attention to the State Climate Summaries, which aren't exactly new. They were created in 2017 and have recently been updated with additional data, improved figures, updated text, and addressing the recent trends and notable climate and weather events across the country. And they were put together by the North Carolina Institute for Climate Studies, which facilitates climate-related research across the UNC system, as well as its partner organizations, including NOAA's National Centers for Environmental Information. And the link for them is posted there as ncics.org. And they're the ones that actually really put these together. So the state climate summaries were produced for all 50 states, plus Puerto Rico and the US Virgin Islands. And they cover topics such as historical climate variations and trends, future climate model projections of climate conditions during the 21st century, and past and future conditions of sea level and coastal flooding. So the link is provided here, and when you first get to the page, you'll see a map of the United States, including Alaska, Hawaii, and Puerto Rico. You can just click on any state you're interested in, or up in the top, there's a gray box there that you can get additional information, extra materials and downloads and everything like that. And so when you click on a state, you'll notice each summary contains key messages as well as a description of historical climate conditions in the state, and climate conditions associated with future pathways of greenhouse gas emissions. There are several updated graphs and figures that you can click on each of these to see them a little bit larger or print individually, however you'd like to use them. And so it just basically gives you a couple of pages talking about climate trends and future projections. So for the Southeast region, just some key points to take away from these climate summaries, and it's between usually temperature, precipitation, and sea level rise. The temperatures in Alabama have not risen since the beginning of 20th century, which is one of the few areas globally to experience no net warming. However, most of the region has seen temperatures rise, and under the higher emissions scenario, much more warming is likely to occur. Future changes in precipitation are very uncertain. However, extreme precipitation events are projected to increase, along with flooding and droughts. And as far as global sea level rise, it's expected to rise in the southeast as well, which could lead to coastal flooding, saltwater inundation, and the destruction of some coastal environments in the region. So this is just basically to give you a summary of these state climate summaries, and hopefully you will all check them out. And yeah, so with that, I say thank you, and I'll toss it back to Meredith.
That's great. Thank you so much to all of our presenters today, Sandra, Jeff, and Pam. My name is Meredith Muth. I am a regional coordinator for the National Integrated Drought Information System, NIDIS, who co-sponsors this monthly webinar series with the National Weather Service and the Southeast Regional Climate Center. So again, thank you for joining us today. If you have any questions or even comments, feel free to put that in the question box. We also have a couple of regional experts on the line for very familiar with the climate impacts and climatology of the region, so feel free to utilize this expertise. As a reminder, we will be sending out an email link hopefully today with the recording and key takeaways. Feel free to share it. Our next webinars will be in March. We'll be joined by Melissa Griffin from the South Carolina State Climatology Office, who will be talking about the CoCo-ROS network, which is a wonderful opportunity for citizens to help the broader community better understand weather and climate through citizen science. It's March Madness, always recruiting new volunteers, so please join us then. And then in April, we'll get a little bit more to the wet side and talk about acidification in the US Southeast. If you haven't taken the quick survey that will pop up at the end, please do. If you have any suggested ideas for topics to further explore, we'd be happy to take your suggestions. This was our first time we had a deep dive into the climatology of river flooding, and Jeff, that was tremendous. Thank you so much. I learned quite a bit. And do check out the state summaries. They're excellent communication products for you to use in your work. So with that, do any of our panelists have any additional comments at this time? I'm not seeing any questions, which means that our presenters did an excellent job of answering all your questions in advance. I'll give it one more minute and then we'll just close this meeting down.
Hey, Meredith.
Oh, we do have questions coming in. Yay. Okay, go ahead. Whoever, is that Victor?
Yeah, I had a quick question for Pam if she's available on that. I guess my question would be what factor did the record warmth or near record warmth in December, and it's pretty much a lack of freezes. How big a factor was that in helping cause or making the January freeze event or the late January freeze event worse or more dangerous for producers or growers?
Yeah, that's a
I
great
guess in other
question,
words,
Victor.
if December would have been near normal, temperature-wise, would the damage or the possible damage from the freeze, from the late January freeze have been as significant as it was?
In the areas in South Georgia where we do a lot of blueberry production, the plants are almost a month ahead of where they normally are, and a lot of that is because it was cold enough in November that they started to get enough chill hours so that some of the plants, when they hit that warm December, started to bloom a month early. So as you can imagine, the frost dates haven't changed that much, and so that makes it especially vulnerable to these frosts that happen almost every winter. But if you're basically moving the growing season by a month, then that's going to really affect things. And I think it probably fooled some people too into doing some planting early. It's always a gamble when you're planting in the winter. But for blueberry production, definitely in the southern part of Georgia and down into Florida, the plants were way ahead of normal. Now, I talked to some producers in central Georgia, and it had been cold enough there that the plants were still pretty dormant, so they were not affected by the frost. But the ones in South Georgia definitely were, and they were fortunate that it didn't quite get cold and dry enough for them to not be able to irrigate for frost protection. But it was a close thing in some places.
Thank you, Pam. Jeff, I put a question for you in the box. Is anyone working on the interface of flood climatology and increasing landscape urbanization in the region?
Yeah, that's a good question. Not that I know of. I know for our office, we would like to enhance or use a better methodology for coming up with river flood climatology and expanding that to other scales of flooding, right? This is just river flooding. There's also flash flooding and urban flooding, sort of goes with flash flooding, coastal flooding, but something that would encompass all those. That would be really neat to see, even on a national level.
I know that there's a couple projects underway here at the University of Georgia where they're starting to look at that, because we have some folks that are interested in urban climatology and urban rainfall. And so that is something that is very of a lot of interest to people, but I don't think we're really there yet.
Great.
Yeah,
Oh, go ahead. I was going to say we have a comment from one of our participants, Julia, who wanted to respond to this question. Go ahead, Julia.
Hi, I'm Julia. I'm CEO of IC Change. We're headquartered in New Orleans, but we work regionally and nationally, and we do work on flood risk and measuring floods with community science, and as it relates to urbanization and green infrastructure solutions. And we'd love to work with NOAA. We just don't know why no one's ever reached out. We have a methodology that's been established and work on both the combination of pluvial and tidal flooding. So please reach out. We'd love to work with y'all.
Great, thanks, Julia. I can do a little matchmaking behind the scenes. I know there's a lot of work that's being done on flood risk and impacts, but I think this incorporating it into our broader understanding of flood climatology, also in the context of climate change, would certainly be a really interesting research question with strong applications. Okay, I think that's the last of our questions right now. And so with that, I just want to wish every one of you a wonderful day and hope you can join us next month. Thanks again to our presenters. Take care.